in listen-only mode.
Hi everyone, and welcome to ODTUG's online education series. Today's presentation is version control for PLSQL, presented by Yolam Gerger. This presentation will be recorded and will be available to ODTUG members on the ODTUG website. Please feel free to put your questions in the question box at any time during the presentation. They'll be addressed as they come in. So welcome Yolam, and thank you for being here.
Hey, thank you. I just made a spelling mistake. I forgot a word in my presentation. That's embarrassing. So it's back to normal. So hi, everyone. And thank you, Karim. I see we have a lot of people in the crowd. I don't see your name, so hi, everyone. So let's get started. And please, at any point in time, if you have any questions, feel free to ask them through the question box. I'm monitoring the questions, and it's better if you do this interactively. So just anytime you feel like you have a question, feel free to ask. So my name is Yolam Gerger. I live in the greater Sacramento area, a small town called El Dorado Hills. I'm originally from Turkey. I've been working on Oracle longer than I like to admit, about more than 17 years now. And I'm back home, back in Turkey. I'm one of the founders of the Turkey Oracle User Group. I speak in European conferences. Now I also talk a lot in the regional conferences in the U.S. And version control for PLSQL has been one of the topics that I'm recently very interested in. So we're going to talk about what the problem is. Then I'm going to talk about how we solved it. So this is not all theory. I believe we actually solved the problem. I'm going to go through some implementation strategies, and then I'm going to do a demo because it's really hard to grasp this concept, at least for me, unless I see something live. So I prepared a short video, and I'm going to talk over the video. And like I said, I think it will be more obvious once we go through this. First of all, this is not just an academic exercise. This works. We are in production, and even we are in production in a very large organization with more than 20,000 database objects. And by database objects, I mean code objects, PLSQL objects, packages, etc., not tables. So the number is even higher if you include tables. And this works. They are now, from having nothing, right now they have a continuous delivery pipeline. So it's not just academic exercise. We made this work, and I'm going to go over our challenges and our thought process and architecture. This is very useful. So first of all, obviously you are here, so you are recognizing and acknowledging the problem, which is like an order of magnitude better than everybody who is not here. So thank you for that. This is really a big issue. And if you implement this, you're going to be one of the pioneers in the database world. As far as I can tell, in the Oracle world, there are very, very few people who actually crack this. And you're going to be one of the pioneers. You're going to be doing a huge favor to your team and to your IT organization. And you're going to have the right. It's not over after you implement this, unfortunately, but at the end of this path, you'll be a lot more productive, and you'll be ready to take the next step and ready to tackle continuous delivery. But without version control, you have nothing. I mean, that continuous version control is like the fundamental thing you have to do before even talking about any other kind of improvement in terms of delivery. If nothing else, if you just implement this, you'll deploy the production twice as often as you do now. I don't know how often you deploy to production. Some people do it like quarterly, annually, biannually, sometimes weekly or whatever. But I guarantee you, at least what I've seen on the field, is that if the people implement these strategies that I'm just going to talk about, at least you're going to improve like by double, like twice as often. You're going to deployed twice as often, and in most cases, way better than that. And on average, we see 95% reduction in errors during deployment to at any stage. Like there might be errors when you deploy to test, there might be errors when you deploy to user acceptance testing. At any stage, you'll see less and less and less errors. So there's few facts, and these we have to just accept and base our solution on these facts. Version control is a solved problem in file-based languages. They have a lot of tools. A lot of the software built for version control is actually exclusively concerned with file-based programming languages. Unfortunately, PLSQL is not one of them. I know maybe some of you are writing PLSQL in files, and that's okay. I've seen many different ways of people developing PLSQL. Most common way I see is that they just open Toad, PLSQL Developer, SQL Navigator, or SQL Developer, and just open a package and start typing in a commonly shared database, development database. But there are other ways. But in any case, when PLSQL is executed, when you want to execute your code, you have to load it to a database, and at which point it's not file-based anymore. So I view PLSQL as fundamentally another file-based programming language. It's just some bytes somewhere in the Oracle database. So on one hand, we have these great solutions that solve this problem for file-based languages. So this is on one hand. And on the other hand, we have PLSQL, which is not a file-based programming language. So either we come up with something new. That's one option. We invent a new version control system for PLSQL, or we just use an existing one and come up with a bridge, come up with a solution between them. And I'm going to use this word bridge a lot. We chose this last one I mentioned. We chose to build a bridge because we believe it's the best path forward. There's a very rich ecosystem around Git, a lot of tools, a lot of software that is built on top of Git, around Git. It's silly to try to start from over for a solution that's basically solved. So we think if we just build this bridge between a file-based solution and PLSQL, we're good. There is a difference. If you're going to use Git, this whole thing could be really done. I mean, in theory, you can do a good system with SVN, but we chose Git because it provides a better feature, at least in our opinion. And there's a difference between SVN and Git. Git is a distributed version control system. A lot of people some of you might already be SVN, I see that a lot, or some other centralized version control system. Git is different in that there is no central repository that is physically the source of truth. Every developer has the full copy. Every developer works locally, and they commit locally. Nobody commits to a central system, so there is no central repository to break. Everyone commits locally, and we're going to talk about this a little bit without going too much into the detail. Now, there are a few other facts about the databases, and there's a reason why this is an issue in database development and not an issue in file-based development. Databases have two types of objects. Some accept the create statement, like tables. There is no create or replace statement for a table. And some work with a create or replace statement. Those are nicer, better, and easier to work with a file-based, in a version control system, because you can easily replace the old version with a new one. With tables, anything that works only with create, it's harder, because you can't just replace a table. What about its data, etc.? All sorts of problems arise. However, the good news is 90% of the problem is about code objects, what I like to call soft objects, because you can replace them. In Oracle, the terminology is code objects, apparently. I guess they call the other ones data objects. I'm not sure. So our solution is going to mostly, in our work, we try to automate, in our project, we try to automate the code piece. And we try to semi-automate the table piece, the hard object piece. So what I'm going to show you, I think, pretty much solves the problem related to packages. It's a semi-automatic solution for tables and table definitions. But in our experience, it's been good enough. This is good enough because code is 90% of the problem. And if I can, and we are engineers, right? If I can eliminate 90% of the problem, that's excellent. That's a huge improvement. Okay, in the Java world, quickly, like in any file-based world, but I'm going to say Java because it's most commonly used in the Oracle world. Like best developers in these outside file-based systems work. This is how they use Git. They have workflows. This is one of the workflows. I'm not going to go through and explain of it, but they have very well established, proven workflows that they can automatically use. And these workflows are not manual. So in other words, they don't code in one computer, in one piece of software, and then go somewhere else to go version control. These workflows are deeply ingrained and deeply integrated to the way they work. In other words, they cannot work any other way, but only through this workflow. This is critical because in our case, what I've seen mostly in shops, even where they use version control, there is a manual process involved where they take the code and paste it to the version control system. That's not a perfect integration of version control and development because your delivery pipeline usually goes through databases, and there's like this version control on the side where you copy paste things. That's called backup. That's not version control. So the best developers in Git work in a kind of a pyramid structure, and how high the pyramid and how complex it is depends on the size of the team and the complexity of the team. But basically, everyone works locally in his or her own local environment without interrupting each other. So all these developers you see, and there can be any number of developers, can make changes to any file, to any package, if you will, without talking to each other, without coordinating with each other. Because they each work on a project. So the three people on one side, work on one project. The three people on the left work on other project, and they can do whatever they want. And once they are ready, they can push code to an upstream integration server. During this push, which in Git the term is called push, there are certain quality controls that they can enforce so that crap doesn't go through the cracks. So they can do unit testing, they can do functional testing, they can do integration testing. And if there are any issues, say there are conflicts, because obviously if multiple people work on the same code, same package, there might be conflicts. This doesn't break anything. The only thing that happens is that their push to the one higher up level is rejected. They have to pull from the higher up repository, resolve the conflict, and push up again going through all these checks and these tests, unit tests, integration tests, functional tests, whatever. So they try to solve issues at close to the developer, not at the highest levels. So the higher you go upstream in the pyramid, the fewer errors you should get. And finally, you reach to the final stage where you go from testing, user testing, and pre-prod, and finally you go to production. In this kind of development, when everybody works in her own working directory, there are no queues. no blocking. Nobody blocks each other. It's very fluent. There are no interruptions. If I accidentally make a mistake and make a package uncompiled, it doesn't break another developer. The deployments are automatic. The source code is reliably in Git, so if their computer just crashes, they can reliably get the source code from their backup or from the Git backup or from another fellow developer. Hotfixes can be delivered faster through a different channel. Like I said, great automated testing can be deeply integrated into this process so that you cannot work around it. You can branch any way you like. And like I said, the thing that I love about this most is that the version control rules are enforced by the deployment pipeline. There is no way around it. Now contrast this the way most PLSQL developers work. It's pretty bad. Mostly there is one, there are exceptions, and maybe some of you belong to this exception, but mostly there is one development database, and a lot of people work on this development database. The database is the working directory, and it's a shared working directory. This is insane. These guys each of them have their own working directory, where we have just one working directory, and we share files. How crazy is that? Of course we cannot work productively. And this results in queued access. We block each other, interrupting, and all sorts of problems. No branching, no merging, no really nice way to deliver hotfixes. And it's one pipeline where, okay, we are developing now, then we go to the test database, and there are different staging databases. Everybody has different names for them, but the most common ones are, test, user acceptance testing, pre-prod, integration database, QA database. I've seen these in the field. So there are n number of databases where code moves from one to the other, and there can be any number of issues anywhere, and it's just a crazy race between developers to take one package from dev, run it in test, then fix something quickly in test, but let's not forget to run the same script in user acceptance. Oh, by the way, we have to copy this to pre-prod. Oh, I fixed something in pre-prod. I have to take it back to dev. So we are running in this chaos. Most shops I run into run in this chaos, at varying degrees, but still it's not the best process. And again, SVN is there on the side. Yeah, we use it sometimes. We use it occasionally. But I'm curious, maybe if you like to answer, I'm curious how many of you can reliably say that if our development database goes down, we can reliably recover our code base from our SVN or from our current version control repository. I'm curious if you have an answer. I'm guessing very few of you would be able to say that. But everybody should be able to say that. Are we good so far? Any questions? Any responses?
There are a couple of questions in the chat box.
I didn't see anything. I didn't see anything, by the way. So you might want to help me, Karine, because I don't see anything.
Okay, I'll just read them to you. The first one was, would your process/proposed system work with SVN?
Oh, you pasted them here. Okay.
Yes.
So, okay. So can we use the same concepts you are discussing here with other version control tools as well, like Subversion and Tortoise? Well, first of all, Tortoise is not, as far as I know, it's not a version control system. It's a tool, it's a software, client-side software to be used with Git. So it's not, as far as I know, it's not version control software. With SVN, yes, you can. But again, this switch, I know some of the companies already committed to SVN for their build processes. But see, the database can be run by Git, and your user interface team, your Java team, your C# team can still continue using Subversion. And you can interface easily because essentially all you have to do is take files from one folder and put it into other. That's how you interface. So the database world can be self-contained in Git. I think it's nicer. It's a better bet. If you didn't make a bet yet, it's better to bet on Git than Subversion. It's possible to use Subversion, but if you don't have a solution for database and you're looking for one, Git is the better bet. It doesn't matter that your company is already using Subversion or anything else. It's very easy to integrate them to each other for a build process because ultimately you just copy files. And in Renus, the example I gave, that's how we work. The other question is, would your process proposed system work with SVN? Yes, it would. Yes, it would. But again, same question. Again, the Java guys, the C# guys, or whatever guys can work in their SVN, which is, in my opinion, a big mistake, by the way, at this day and age. But, not everybody is perfect. It's okay. You can create a better system and still interface with the build process that uses SVN. That's how Renus works. The example I gave you. They chose Git. The other team, their application team, still works in SVN. Anything else? I don't see any other questions.
That's it so far.
Okay, good. So we are moving on. Okay, now before I explain the solution that I'm going to propose, I'm going to also talk about some restraints we have, some constraints we have. And we have to accept these facts because we're in the database world. So we can just, just do anything. Like sometimes the environments are very complex in enterprise IT. We can do very little change to the workflows, especially the bigger the company gets, the more conservative they get. Everything becomes too risky to do, and nobody wants to stick out their neck. Good news is there is virtually no risk in implementing a version control solution because what's the worst thing that can happen? You have no version control, and it's not any worse than you are now. There are DBAs we have to deal with because they don't want to increase the number of databases they want to maintain, and rightfully so. So probably we won't be able to have a private database to everyone, and we have to accept that we're going to have one dev database or at most hope for 2 or 3. We cannot enforce a development tool probably, so whatever solution we come up with has to work with all development tool solutions. So it has to be a generic one, and we have to cause the minimal intrusion to the current development lifecycle. So we cannot stop people from working. It should be a smooth transition. So when we built our solution, when we architected our solution, these were the constraints we had in mind. I have a question saying, do any PLSQL IDEs support Git? Yeah, there are. SQL developer has a Git support, I think. But again, it doesn't matter. In our solution, it doesn't matter because here's the difference. Here's the mistake they make. If even the SQL developer makes this mistake, in my opinion, that's a useless support because it supports it locally. So it has Git integration for a local folder you have. What good is that to me when my code is in the database? I'm doing server-side development, not local development. I got one database and multiple people are working on it. It's a shared workspace. What good is it that I have Git in my laptop? And as it turns out, in our solution, we don't install Git to client development machines. It doesn't make sense at all. So basically, we said, okay, we have to find a way to bridge the database with Git. That's the architecture we came up with. And here it is. So we assumed a world where multiple developers work in one database. That's just a fact. We decided to treat the database like a big giant working directory. So what we have done is we have Git installed somewhere that is close to the database physically, preferably on the database machine itself. And we have a working directory which maps one-to-one to our development database. And so I don't want to get into details right now, but we can create repositories, Git repositories. So in one database, we can have multiple repositories. So we can have 10 repositories in one database. But for now, let's assume we just have one. So we got Git, we got a working directory that represents all the code we have in the database. And we coded a bridge. Literally, there is a two-way bridge code that that facilitates the communication between the database and the file system. That is the working directory and Git. So we got one or two database triggers, I think two database triggers that listens to DDL events. So anytime I create a package, a trigger, a view, a synonym, basically whatever I can create using a create or replace command, we listen to it. And how you can do this, you can always Google it. But bottom line, we listen to these events, and we read the code that is being executed, and we write it to the working directory in the operating system. So nobody, no user, no developer can run a script anymore without our bridge noticing it. It's impossible because it's a database level trigger. When we issue a git command that changes the folder, changes the working folder, say we want to move to a previous commit point in our version in our history because there was an issue, we want to just go back or forward. When we issue that commit, there is another event happening. When the working directory is updated, we immediately synchronize the database with those changes. We don't run every script. We only run what's changed. It gives us this ability. So we say we go back in a step. We go to a previous state of the database. Git tells us what has changed, which packages have changed. We take these scripts and execute them in the database automatically. We do this automatically. And this bridge is really just some Java code and some PLSQL code. So obviously, one additional step that is required for developers is that when they open their editor, whatever that editor is, they have to log in to our bridge. The bridge has to know who this person is who is executing these packages, executing these DDL scripts. This can even be automated. For example, Renus chose to automate it. In our internal development, we don't automate it because it's one line of PLSQL code, and it's okay with me. But some people are really lazy. Because it can be a login trigger, and the login trigger can detect who you are. And in some shops, the database user, a developer, is connecting to work in the database is actually his or her own username. So it's easy to detect who he is. Sometimes it's not. Sometimes everybody uses the same username, but the login trigger can be smart enough to detect the machine which is connecting and figure out who that person is. And that's what they do at Renus. And we also build PLSQL APIs so that PLSQL developers don't have to learn Git and just do some operations if need be. For example, if they want to commit something, so they might work on things, change a few PLSQL packages, say to fix a bug, and when they are ready, okay, I'm ready, now I want to commit, they can run a simple PLSQL API and commit their changes. So that's pretty much how we work, really. and in the coming slides, I'm going to show you the benefits and how far we can, how far we took it, and how far we can take it. Any questions about the setup? One thing I didn't mention while you guys are typing the questions, when we want to move our code from dev to test, again, we don't generate scripts. All we do is to execute what's called a pull command from one Git repository to the other. So from test, all we do is to issue a pull, which is a Git command, and we do this through the bridge APIs, and all we receive is this incremental script that will take my test environment from where it is to the exact point where dev is. So we don't have to carry all the packages, thousands of packages, or we don't even forget any packages because it just all happens automatically. And we do this even via API. Yes, the question is, will we see an implementation of this bridge? Yes, at the end of this talk, I have a 15-minute demo. It's a video. I'm going to walk you through a scenario. No worries. This is not academic talk. It's all real. Any other questions? All right. So far, so good, I guess. Now, just step one. All we do is implement bridge to our existing setup without changing anything. First day, I just built this bridge and installed it to my dev. And when I move forward with my code base, I keep implementing it. The next time I have to deal with test, I install it to test. The next time I have to deal with user acceptance, I install it to user acceptance. And the next time I have to deal with prep route, I install it to prep route. Look what I have by, oh, here's a question. So the Git repositories are Oracle schemas that the DBA must create first. Well, the schemas already exist, right? I mean, you are working in the database. You have to create the Git repositories, and these repositories, they are basically, are synchronized with the code you have in the schemas. And yeah, DBA can create, yeah, it's probably the job of the DBA to create these repositories. But the schemas already exist. Like, that's your development environment. You create the repositories, not the schemas. I mean, the assumption is you have code, PLSQL code in the database that you want to manage in Git. Unless I'm missing something. So even if we just have this control layer at every database in our pipeline, I still have queued access. It's still blocking and it's still interrupting. But notice the difference. The source code is now in Git, and reliably so. There is no way a developer can interact with any of these databases without interacting with Git. No way. Because the way we implemented this is we don't let developers execute DDLs without logging in first. Literally, the trigger, the DDL trigger fails. The DDL doesn't execute. So they have to log in, which is great. And we are enforcing version control rules at the database level. It's not a side thing, a manual procedure the developer has to follow. Again, great. It's integrated, deeply ingrained into the way we work. It's just part of it. It's not something we have to remember on the side. We can even do faster hot fixes. This is very interesting. Usually companies have these pipelines and they have these hard rules. Okay, we have this, but nobody can change any code in tests. Nobody can change any code in user acceptance. Nobody can change any code in prep-route. Yet, there are always emergencies, always, and we do that. And most of the time, we forget to carry that change over to dev, or it gets forgotten, it gets overwritten with the next deployment, and chaos ensues. If we have Git installed and integrated to each database, this stops being a problem. You can freely and easily go to a pre-prod database. As outrageous as it sounds, you can go there and make an edit to a code and ship it to prod. There is no way you can overwrite that code anymore. Because pulls in Git, if you pull code from, say, user acceptance to pre-prod, it's not an overwrite. Git does not do an overwrite. Git does a merge. So there's a copy that I'm pulling from user acceptance. There's a copy that I have in pre-prod. If these two are not identical, Git merges them. And as a result of this merge, two things can happen. If the merge is fine, there are no conflicts. If that is the case, our bridge executes this code in the database. Almost always, if there are no problems, almost always the code compiles. So a syntactual error, if there is no conflict, it's not impossible. Theoretically, it's possible, but it's extremely rare. If there is a conflict, well, there's a conflict. Somebody has to take a look at it, which is great. At that point, you can now do the right thing and do the merge and maybe remember to pull the code back to dev from pre-prod. So nothing gets lost, nothing gets forgotten, there are no issues. While you move code from one database to the other, Git has hooks. So you can always initiate certain quality checks. You can implement unit tests. You can implement integration tests. You can implement functional tests. Any kind of precaution you can think of, you can implement it, which is, again, great. And as you see, even though it's not officially a branching, we have rudimentary branching here where we can apply hotfixes in the development pipeline without the fear of losing them. And the way we generate scripts to go to prod is not to run a diff or remember how we remember what we've changed. We can simply run a git command and tell Git, you know what, my production is at this commit point, say X. Right now, in pre-prod, we are at this new commit point, which is Y. Give me the diff script, differential scripts, that can take me from X to Y, and Git will give it to you. And that's going to be a valid script that you can run in production. What more one can ask? Any other questions? So I'm going to move to step 2 and make things even more interesting. Good. That's a great question. How would Git interact with addition-based redefinition? That's an excellent question. And Git and addition-based redefinition are part of the same path. Git is the path from dev to the pre-prod in this diagram, and this black arrow you see from pre-prod to prod is addition-based redefinition. So when you're ready, when you generate your script to go to production, you have to create a new addition in your production database and run your script in this new addition. That's how they interact. Git enables you to create the script so that you can create your new addition in production. Addition-based redefinition is only used for live deployments. Nothing else, nothing else. Addition-based redefinition has nothing to do with version control. This is very important. A lot of people confuse it. It has nothing to do with version control. It's about upgrading your application in the database with no downtime. That's all it is, which is great. And very complicated thing, which made very simple by the Oracle database. But to make that happen, you need a script, right? To create your new edition, you need a script. Where are you going to get that script from? Either you're going to keep trying and failing, or you have a script that has a very high probability to be correct script. And this version control implementation gives you that correct script very quickly and reliably. Any other questions? Okay, it doesn't look like we have any other questions. I'm going to move over these very quickly. Oh, here's one. For the pieces of development which are not code, so let's say 10% data-driven design, DML is required. How can you get DML into this pipeline? You can, and we are working on it. I'm not going to talk about that in this presentation. What I'm going to talk about is this other DDL thing, tables thing. Table solution, a semi-automatic solution. Theoretically, you can apply the semi-automatic solution that I'm going to recommend for data-driven design as well. It has some human elements, some manual elements, so it's error-prone, but it's not bad. I mean, we like it, so it's better than nothing. We are working on automating that piece as well, but I won't be able to show you an automatic solution today. Maybe next webinar. So next step, and once I'm comfortable working in the previous picture, maybe now it's time, dare I say, to add another development environment, maybe another database. Now all of a sudden I have two development databases. I have fewer queues, less blocking, less interruption. Maybe this new database is my hotfix database. Maybe it's a new project that's going to take a while to finish. Or maybe I just split my development team into two. And it's just fine. Now I can be more productive. And there is no side effect on this. There's only good things happen. I have fewer queues. The more dev databases I have, the fewer queues I have. The more development databases I have, the less blocking I'm going to become, and there is going to be less interruptions. Isn't that great? And now I have a solid infrastructure to slowly implement this in my department, because we're going to see the success from the first implementation, and everybody is going to be encouraged to implement this solution because it's obvious it's going to work now. Everybody is more confident. Now, if we take this up to the extreme, to the whole level, this is what we're going to end up with. And this is the exact same picture, just drawn differently, as the picture that I've shown in the beginning, where there is no difference. We can be here. Every developer, every database developer can work in her own environment privately and release her changes, commit her changes to a project server, to an integration server, and depending on the complexity of your organization, you can have an upstream pipeline. Why not? This is quite possible. And the benefits are enormous. There won't be any queues. You can divide up your team and have them work on anything without worrying about overstepping on each other's toes. Nothing is blocked. They will work like the best developers in the world. This is how even the most sophisticated developers work this way. There is nothing else. That's as far as it goes, as far as version control is concerned. And this is the journey that Renus is on, and we are already here as a team. So now I'm going to do a demo. Any questions before the demo?
We just had one come in. I'll put it in right now.
All right. In the meantime, I'm going to prepare my demo. Oh, I have to still show this, the demo setup. Does the solution require that the schema name match between the dev, test, prod environments, or multiple branches exist in the same database but different schemas? That's an excellent question, and we thought of this. No, it doesn't require. It doesn't require. The way we implemented is that you can, when you move code from one database to the other, or even in the same database, if you have like one branch in one set of schemas, and I can't believe there are actually. I was wondering when we were coding this, I was wondering, is there anyone out there who uses multiple schemas and keeps multiple branches? No, that should be complicated. So apparently there is one. Well, yeah, we support this. So you can have multiple branches spread out to multiple schemas, and you can move your code from in the same database from one set of schemas to the other set of schemas. All you have to do is map. While you do this, you have to map which schema goes to which target schema, which source schema goes to which target schema. This is how our solution works, basically, in Renus. It was a bit of an overkill, but apparently people like this. Can you see this working with Apex? No. That's what I don't like about Apex. And I'm sorry I'm going to give some crap about Apex. I apologize. I know a lot of people like Apex, but Apex doesn't have a version control solution, and anybody who's building a complex version control solution, building a complex Apex application, is basically cornered in this. There is no good solution. Full disclosure, we are building. I have interest in this. We are. Maybe some of you already know, and maybe they are our customers, but we are building an application development framework for PLSQL developers, which is a competitor to Apex. It's called FormSpider, and in FormSpider, we built in this version control solution from day one, because I cannot imagine a system where this doesn't exist. It doesn't exist in Apex, and as far as I can tell, the only way you can get this is to use FormSpider in PLSQL world. Sorry. And quite honestly, I don't think it's doable. I don't think it's doable. That's the other part. I mean, theoretically it might be possible, but practically I doubt that anyone will ever do it. They always end up being backup solutions in the end. Okay. So this is going to be what I'm going to demo. I'm going to have a dev1 database where multiple developers are going to work. I have another screen here. That's what I'm looking here. But I'm going to have only one developer just to make this simple enough. In dev1, I'm going to have one developer. In the dev2 environment, I'm going to have one developer. I'm going to have a central database. I'm going to call it preprod, but it can be anything. Call it test or whatever. And that can be n number of staging databases before production. But what I'm going to do is we're going to start with code in preprod. It's not even in the repositories yet. We're going to put it in the repositories. Then we're going to pull that code, clone that code to dev1. Then we're going to clone that code to dev2. We're going to modify it in dev1. We're going to modify it in dev2. Then we're going to pull that code from, then preprod is going to pull the code from dev1. Next, preprod is going to pull the code from dev2 to preprod and do a merge and solve conflicts. I'm really sad about what you said about Apex. Well, it's a conscious choice you're making. If you are using Apex, you have to live with it. The question is, do you want to live with Apex? I don't, and many others don't. To me, it's a dead end. But the story sure starts nice. In any case, let's focus on this. So this is a demo. And in the demo, I'm also going to add columns to the tables, in both development environments. I'm going to add columns to the tables. I'm going to show you how we solve that problem. Hang on. So let me open the video. Oops, no, I don't want to use this. Okay, again, at any time, I'm going to keep an eye here on the questions. Okay, so we're going to start from the beginning. So basically, this is our code. It's in preprod. We got 3 tables, some packages called NU, and some sequences. You don't have to do this, but we built a UI for this. So I think it's easier to communicate if you do it via UI, but there are PLSQL APIs for the whole thing. So at first there is nothing. I don't even have a repository, so I'm going to create a new repository. The demo repository. There's a default schema. It's called the demo schema. Throughout the demo, I'm always going to use the same schema names. That's only to make things simpler. That's the only reason I'm going to keep using the same names. And I got nothing. Now I'm going to add my code to my repository. And like I said, we built a UI. You don't have to. It's just PLSQL APIs. So I'm adding these packages. From this point on, my bridge is tracking these packages and only these packages. And I'm doing my initial commit. So these are the things that I checked out. Green means I checked out. Initial commit, I commit, and my repository shows that I committed everything. Initial commit is done. So the next thing, I'm logging in to dev. Notice that I'm logging into dev here. So this is a different database. We have a separate installation for each database. So John comes in as a developer who works in Dev 1. There is nothing in this database. It's all empty. But this database knows where the preprod database is. So we have a connection between those two. So I can pull from it. So John comes in. He wants to start working on this a new project. The first step he does is he clones the project. So this is going to create an exact copy of the NU project in the dev in the preprod from the preprod schema in the to the dev environment. I'm just cloning it. I'm giving it the same name. I don't have to. I'm giving the same default schema name. I don't have to. As you can see, you can actually map. So the name can be actually different. I click OK, boom. The history is here, the commit history is here, and then I open the node here. I see all the objects are here. They're all moved. And then I go to the database. I'll actually see that my objects are automatically created for me. The tables are not there yet. We'll get there, but everything else is created. Any questions so far? Are we good?
We're good so far.
Okay, perfect. So moving on. Now, of course, I want my tables, otherwise the whole exercise is useless. What we do is we have a package called model. We always, in our projects, we always have a package called model which contains our model, which is just basically a bunch of execute immediate statements that contains create table statements in themselves. That's all there is. And they don't stop, so they're nicely wrapped up so that if one fails, the next one continues to execute. So every time we do this, we always create this package called model package. We manually put our table DDLs or sequences or whatever. We put it in there, into that package, so that that package can, when executed, that package can create our tables and other objects. And then all we do is to execute that package, really, to have our model. See, the trick we do here is we change the problem of these hard objects, of these table objects. We switch the problem from being hard to a soft problem. Now it's a file-based problem. It's just another package. So that difficult part where we can't really manage DDLs is gone, because it all of a sudden the whole thing turned into a package that I can put into Git. So that's the trick we do. That part we do manually, but once it's a package, it's again a file-based system. I don't know if you hear this, but there is a storm just started here. It's really loud. California is crazy these days. So yeah, that's the only trick we do. And so a bunch of create or replace statements here. And all I do is run my package. And boom, I have my tables and sequences and everything I need. Now the next thing, so the sequences are here too. Now the next thing, we're going to move over this really quickly. Obviously, dev2 repeats the whole thing. I created dev1. I'm going to repeat the whole process for dev2. I'm skipping over this really quickly. So basically, same exercise. Packages are created, I'm done. So dev1 and dev2 have now the exact same copy as preprod. Now the real work begins. John comes into dev1 and makes a modification. He's going to make two modifications. The first modification John makes is he's going to add a procedure. He's going to add a function, I believe. Yeah. So, but hang on, something interesting happened here. I got an error. Let's run this again. I got an error. I tried to save, but it didn't work. The message says, package NUPKG is being managed by version control. Log into version control management system before modifying it. So no one can really run any scripts for objects that are being managed in my solution. I can run a new script that is not managed in my solution, but if this package is being managed in Git, then I don't allow anyone to override it without signing in first. So we sign in. There's one line of PLSQL API, login. We sign in. Now we can save. This, when I save this, immediately there's code that executes behind that immediately synchronizes the working directory in the operating system folder. So I have a file there, which is basically a create and replace, the exact same copy of the package here. That there's literally a file there. Now the next thing I'm going to do, and we do this to create a conflict. And towards the end of the presentation, you're going to see a conflict. I'm modifying a function. I'm changing its value from 7 to 77. Remember this because the other developer in the other dev2 environment is going to enter a different value here, and that's going to cause a conflict. So I save, all good. I'm going to also, for good measure, I'm going to also add a column to the table. So I add a new column to this log table, and I add this column to my model package. So this is the syntax we use. We just want to make sure that, since we're executing this, the column doesn't exist. I mean, this whole thing can be just as simple as begin, execute immediate, alter table, and exception when others stand null. That also works. And we save this too. And remember, I'm going to commit this to Git as well. Okay, so now if you look at it, in my UI, again, this helps, having something visual really helps. I notice that I'm connected as John, and 3 packages are checked out by me as John because John modified them. So when I want to commit, so if some other person changed some other package, I won't be able to commit these changes. They'll show up here as red logs. So they are checked out by someone else. I cannot edit them, but I cannot also commit them. So I commit my changes, it may be the case sometimes that, I made 3 changes, but they were unrelated. I might be working in 2 different tickets. So I might not want to commit all 3 of them in one logical unit. So I can include or, exclude these packages from my commit. And I can also look at what I'm committing. So I can do a diff and see what this new thing that I'm committing is. Because, maybe I've been working on it for a while, I got distracted, and I forgot. It happens. So Git provides this diff. This comes directly from Git. I can look at each package and see what I'm committing, which is beautiful, and decide not to commit this particular package. This time I decided to commit them all. Usually you must give a commit message in Git, which is wonderful, and usually what you put here is an issue ticket number and some explanation. Done. And as you see, it's in my history. I can see what I changed. Later on, months later, I can come in here and look at the changes that I made here in a very nice UI. Red is deleted. Green is the things that I added. It's just exactly what I want to see. Now, dev2 repeats the same thing with one difference. Smith, who works in dev2, makes a new edit in a new package called Neuron query, but he also edits the same function that John edited in the other copy, in dev1. So, but this time, in his own copy, he changed the value to 99 as opposed to 77. So this is going to cause a conflict because it's the same line that both are changing without talking to each other. And again, Smith edits a column and modifies the model package in his own copy. So both developers made changes to the model package, which is managed by Git. Okay, so again, in his own environment, Smith just makes a commit locally, doesn't know what the other guys are up to, just he fixed an issue, and that's it. Now we're going to pull. Now we are at pre-prod, and we're going to pull. But before I move forward, I want to see if you have any other questions.
No new ones.
Okay, so I'm assuming everybody is with me? Okay, so now we are pulling. So both development teams are ready and they want to go to production. So this pre-prod environment, the test environment or whatever, has to pull this new code from these development environments. So I'm in pre-prod. This is the Git UI that we built for Renus. And I'm doing a pull. So I'm picking dev1. I'm picking the remote repository. There is only one anyway in that remote destination, demo. And I can pull from any branch, but because you can branch, but there is only one branch in this example, which is master. And I click OK. And that's it. Merge completed. The new code arrived to the pre-prod environment, and it's executed in the pre-prod database. As you see, the history also arrived. So if I go to pre-prod and refresh, I will see that the NU package is updated with the new function built by John. And the util package, a new util package, has this new value 77, which is also something that John did in his own environment. And it's all here automatically. And only the things that have changed moved. Nothing that isn't changed is moved. So even if you, like in Renus, you can have like 20,000 packages, but if you only modified 50, it's really quick. This change is really quick. And there's no way to make mistakes. But however, notice that the column is not still here. To have it here, I have to run my model package again, because the new model package has the new piece of code that creates this new column. So that's what I do. I simply run my code and my model, and I got the new column. Now I'm going to pull from dev2, and this is going to cause some problems. I'm expecting a conflict. So I'm picking dev2. Again, these are just PLSQL APIs, and actually in Renus these are running daily, and they do daily builds. Pull completed with issues. So there was a pull, but it didn't complete it as expected. Please review the issues and resolve them to finalize the pull. So there was issues. There was a conflict as expected. In this case, we provide a nice UI, but this can just be a message. So there are two packages that cause problems. One is the model package. That happens because both developers added their code to the bottom of the package. So it looks like a conflict, but it's not really a conflict. But the other one is really a conflict where two developers make the function return different values. That's an honest-to-God problem. This is just a notepad. Nothing really happens here. There is no functional thing happens in this UI. You have to go to the SQL developer or whatever you're using and fix these issues. So what we do is in those cases, this is what Git gives you. When there's a conflict, Git just merges these two things, the two code that it found in both environments, and it's like, okay, this is what I can do. I don't know, figure it out. In this case, both if statements in the model package are merged together in a silly way. But this is a very easy conflict to solve, because basically I want both if statements there. So all I have to do is make it compile correctly and save, and I'm already logged in, so I'm good. And I just run my model, and I got the latest model. So I just, in the notepad, I check that this is done. Now the second one is more interesting. When I look at the result, the package is returning 77. Now the other developer, Smith from Dev2, wants it to return 99. Now, obviously, in such cases, two teams, two developers, two parties have to come together and come to an agreement. In shops where they use Git correctly in a distributed environment, sometimes they have like pizza parties, merge parties, where they resolve these conflicts. The rule of thumb is you have to merge often. You don't have to stray away from your master for too long. So in this case, in our case, Dev1 or Dev2 should pull from preprod daily or as often as they can, so that they don't stay behind too long, and whatever conflicts that occur, they resolve locally, not in the preprod database, but in the local environment. So these are the best practices. But I just wanted to show with you here that this can actually happen. There is one question. Do you find that code formatting and conventions are important in reducing extraneous conflicts? If so, do you have any suggestions for these? I don't think so. I mean, Git has some settings for this in our team. Renus didn't complain. We don't complain, but then again, these teams are highly organized teams. Git is smart, so you can configure. I'm not 100% sure on this, so take it with a grain of salt. But Git is smart. So like empty spaces, etc. Git can be smart about these things. So you're not gonna get a lot of false positives. Git is smart. I mean, those problems are solved already. I mean, millions of people are using Git, and they all run into this problem. So there are settings for Git to ignore spaces and such things. So I don't think it's going to be a problem. At least it never has been a problem for us or in any implementation that we did. So developers get together. Yeah, I'm almost done. I'm a little over, but you know that's the beauty of doing a webinar. There is no next room there is no next presentation to leave the webinar for. So I mean, that's a good question, Karen. I want to take these, and I can see that they're really engaged questions. Can you compare your solution to built-in version control support in SQL Developer? Yes, of course. That's not a solution. The built-in solution in SQL Developer is nothing like this. Basically, for that to work, you have to. There is no locking involved. There is no central repository. There is no central Git control involved. Like people can overwrite each other very easily. There is no coordination involved. It assumes local Git installation on your machine. We don't do that. It's all in the database, and it's all in the server side. You can connect remotely to an Amazon cloud service from a machine that belongs to your friend and still be in version control with this solution. SQL developers is just, they basically punt the ball. To me, it's not a solution at all. I don't understand why it even exists. I mean, it still doesn't solve the problem of communication and coordination between developers. You still have chaos. Everybody has its own version in its own repository. And if you want to run your modifications in the database, what are you going to do? You're going to override other people's changes. And how are you going to tell which packages you changed? You don't know. You have to learn Git. Oh, that's great. Are you going to run like 20,000 packages? No. You have to figure out which ones you modify. So to me, it's not a solution at all. I mean, it's really day and night. Okay, so they decided on 88 as an intermediate solution. So this is how they resolve the conflict. So none of these things you can do with a SQL developer solution. Now, I'm going to do a final commit to complete my merge. And I'm done. I got the full history. Both changes are here now in pre-prod. Now, one final thing remains. Obviously, I want to be able to continue in Dev 1. And obviously, I want to continue with the latest code from pre-prod. I don't want to continue with what's in Dev 1 because there are new things coming from Dev 2. So I have to pull, Dev 1 would like to pull code from pre-prod at some point, the new code. And it's really easy. All I have to do is pull. That's all I have to do. Go to pre-prod and pull the code. And since all the conflicts are resolved, the whole thing's going to run smoothly. And my database is going to be up to date. All I have to do is run my model. Just that. I run my model, and I'm done. I got all the modifications, all the results, the conflicts are resolved, which is exactly what I wanted in the first place. So I'm done. That's what we do. I think we all have to work this way. And I think this is incredibly productive. Any questions?
Nothing new. Nothing new.
Okay. So thank you very much for your time. If you are interested to learn about this more, feel free to contact me at my email address. You can also learn more about our solution. There are a bunch of webinars and videos at this website. And, you know, I'd be happy to talk to you about your specific issues because, you know, everyone is a snowflake. Everybody has its own particular issues. So, you know, we do free consultations. I'd be happy to talk to every one of you. So thank you very much for your time.
Thank you so much for joining us today.
You're welcome. Thank you for having me.